Hey gang, today we're going to be looking at quadratic word problems. Let's do the odds together. So the length of a rectangle is 12 feet more than twice the width. The area of the rectangle is 320 square feet. Find the dimensions of the rectangle. So this is similar to when we did perimeter, but now we're talking about area. So let's draw a rectangle and label what we know. The length is 12 feet more than twice the width. So we don't know the width, so we're going to call that x. And the length is 12 feet more than twice that. So that's 2x plus 12. Now remember, area of a rectangle is length times width. So this is going to be x times 2x plus 12. And they tell us it's 320. So there we have our equation. So now we're going to distribute the x, which gives us 2x squared plus 12x equals 320. Now we could solve this by completing the square, or we can solve it by factoring. Because we did completing the square most recently, I'm going to go back to factoring so we remember how to do that. So we're going to subtract the 320 from both sides. So that's 2x squared plus 12x minus 320 equals 0. Now 2 is a common factor there, so I'm going to get rid of that. So that's 2 times x squared plus 6x minus 160 equals 0. Now I need my factors of negative 160 that are 6 apart. And if you think about it, well, 16 times 10 makes 160. So if I do 16 and negative 10, I would get positive 6. So we have 2 times x squared plus 16x minus 10x minus 160 equals 0. Grouping, we get 2 times x plus 16 minus 10 and 16 have 2 in common. So I can take out the 2. Oh, 10, sorry, 10 and 160, not 16. I'm seeing it wrong. 10 and 160 have 10 in common, so I can take out the 10. And again, I get x plus 16, because a negative times a positive would make that negative there, equals 0. So now I can bring this back up here. I've got 2 times x minus 10 times x plus 16 equals 0. All right, so my two things that I can set equal to 0 here are the x minus 10 and the x plus 16. This 2 on the outside doesn't matter. So x minus 10 equals 0, or x plus 16 equals 0. Adding 10, I get x equals 10. And subtracting 16, I get x equals negative 16. Now, if we're talking about area or lengths, the negative is not going to work. So we're going to choose x equals 10. We're going to plug that in. So x here is 10. And then 2 times 10 plus 12 gives us the length. So that's 20 plus 12, which is 32. So the dimensions of the rectangle are 10 by 32, and feet is our unit. And that makes sense because 10 times 32 is 320. All right, let's take a look at another one. Number 3, Stephen is building a deck in his backyard. The plans for the deck show that it is to be 24 feet by 24 feet. Stephen wants to reduce one dimension by a number of feet and increase the other dimension by the same number of feet. If the area of the reduced deck is 512 square feet, what are the dimensions of the deck? All right, so again, we have a square, and it's 24 by 24, but he's going to add a dimension to one side and subtract that same dimension from the opposite side. So we have 24 plus x and 24 minus x as our length and width. And that gives us a new area of 512. So now we double distribute. 24 times 24 is 576 minus 24x plus 24x. And then positive x times negative x is negative x squared equals 512. So I'm going to rearrange this and write negative x squared. And then the 24 and negative 24 cancel out. So plus 576 equals 512. So there's two ways I can go about this. I could solve this like a very simple equation because there's no other x value here, or I could set it equal to 0 and have a difference of two perfect squares. I'm going to make my life easy. If I subtract 576 here, I get negative x squared equals 512 minus 576. which is negative 64. And then if I divide by negative 1, doesn't want to write the 1 for me, I get x squared equals positive 64. And then I can take the square root, and I get x equals 8 or negative 8. So if you see that opportunity where you don't have to factor, go ahead and not worry about factoring. It does make it a little bit easier. So we're going to choose the 8 as our value because we don't want negative 8 as a dimension. We plug in the 8. 24 plus 8 is going to give us 32. And 24 minus 8 is going to give us 16. So that makes our new dimensions 32 feet by 16 feet. And if we check, that should be equal to 512. So 24 times 16, in fact, does not equal 384. What did I do wrong? 32 times 16. Uh-oh. I did 24 times 16. 32 times 16. Whoops. Haha. Does equal 512. I thought I did it right. I didn't see any wrong work. Okay, so again, be careful because something simple as that could throw you all off and you could think you're wrong. All right, let's take a look at the next one. Number 5. Algebraically find two consecutive even integers that have a product of 624. Okay, so we go back to that idea of integers. So even integers, we start out with x, and then we have x plus 2. Two consecutive even integers that have a product. Whenever you hear the word product, you should be thinking quadratic. Okay, perimeter was linear. Area is quadratic because we wind up having that x times x. Okay, so in this case, when we did sum before with consecutive integers, that was linear. Product is going to be quadratic. Okay, so x times x plus 2 equals 624. And they will get much more challenging like that than this one, like as you will see coming up shortly. X times x and then x times 2 gives us x squared plus 2x equal to 624. So we could complete the square or we could factor. If we complete the square here, half of 2 squared is 1. So that's x squared plus 2x plus 1 minus 1 equals 624. This is our perfect square. So that's x plus 1 all squared minus 1 equals 624. Adding 1, we got x plus 1 all squared equals 625. Taking the square root, we get x plus 1 equals plus or minus 25. 625 square root is 25. So I actually prefer to write this as 25 and negative 25. I think it looks better that way. So it's 25 or negative 25. Subtract 1, and we get 24 or negative 26. So we're talking about all pairs of consecutive integers here. So both of these choices actually work. We wouldn't cancel either of those out. So we could have 24 and 26 or negative 26 and negative 24. Both of them would have the same exact product of 624. All right, so I gave you a whole bunch of different ways to solve them. You can solve by completing the square or solve by quadratics. Sometimes it's up to you. Sometimes it will be asked to do it a specific way. So you have to remember both procedures. All right, so you're going to go on to the evens on your own. I'll be around to help you out.